All right, here's number 4. Suppose that Marlon wanted to prepare 2.8 liters of a 3 molar sulfuric acid solution for a lab he wanted to do. He goes into the chem stockroom and he finds a gallon of concentrated sulfuric acid with a concentration of 18 molar. So we can tell right away that this is way more concentrated than we want. We want a solution that has a molarity of 3, and our stock solution is very concentrated with a molarity of 18. To sort of put this into perspective, let's say that this is our gallon of 18 molar sulfuric acid. The solution that we want to make here is smaller than the gallon that we have. So the volume is less and the concentration is less, which means that let's say that's 1 gallon and that's 2.8 liters. So that means we hardly need any of this in order to make the 3 molar solution that we're trying to make here. So this is a dilution problem where we're solving for initial volume, actually. So we got Mi times Vi equals Mf times Vf, where we know the initial molarity, that's 18 molar. We know the final molarity, that's 3 molar, and we also know how much of the 3 molar we want to make. So we can solve for Vi real quick. If we say Vi equals Mf times Vf divide by Mi, plugging numbers in, we'll get 3.0 molar times 2.80 liters divide by the initial molarity of 18. And we'll get Vi to be equal to, hold on, let me just punch it in real quick. 3 times 2.8 divide by 18. I got 0.4666 repeating. For sig fig reasons, we'll go to 2 sig fig, so 0.47. And that is the volume of 18 molar that he should start out with. So he's going to pour out a little tiny bit, well, not that tiny, but he's going to pour out 0.47 liters of 18 molar, and then he'll add water to that in order to make his final solution. This is the dilution equation. So when it says describe the procedure, we have to understand that this 0.47 is the volume of concentrate that we're starting with. So the procedure should be measure out 0.47 liters of 18 molar acid. Then we're going to add water to that solution. So we just need to figure out how much water do we add. The way we can do that really quickly is just by subtracting the initial volume and the final volume, because this is how much concentrate, this is how much concentrate he's starting with, and this is how much solution we want to end up with. So we can find the difference, and that's the amount of water that he should add. So I'll go 2.8 minus 0.47. I get 2.33. And that's it. Now, technically, there's a safety concern here, which you don't need to know this for the test or anything, but technically you should always add acid to water rather than adding water to acid. This is because when you mix water and acid, especially concentrated acid like this, it releases a lot of heat. So if you add the acid into the water, that heat gets kind of like spread out over time and space, so it's a lot less dangerous. So technically, I guess we should measure out 2.33 liters of water and then add to that 0.47 liters of 18 molar acid, but whatever, close enough.